so looking at Unit 1, review of Calc 1, area and volume. So we're going to start off with a discussion involving sigma notation. Alright, so this is stuff that you should have seen before, but I take no chances. Alright, so first thing that we talk about is the actual notation itself, the capital sigma. Alright, so it represents a sum. Alright, a sub 1, a sub 2, a sub 3, and all the way to a sub n represent the terms of the sum. Alright, so if we wanted to write a simple expression involving the sum of several terms in sigma notation, it could be something as simple as what you see here. Alright, a sub 1 plus a sub 2, a sub 3, all the way to a sub n. Alright, you see that the a's are constant, they don't change, but the subscripts do. The subscripts span from 1 to n. So what we do is we create an index. That index of summation is what they call it. But we create that value, kind of like if you're familiar with Excel, it's kind of like a row or column reference, right? But it is an index, right? It tells the formula what term of the sum you're working in, all right? So if I'm looking at I equals 5, it would be the fifth term of the summation, all right? So since the a doesn't change, we can assume that to be part of the expression. All right, so these a's stay put. The subscripts go from 1 to n. So what we do is we create an index I that we span from 1 to n. All right, so the I value goes from 1. So it's really I equals 1 on the bottom to, the sum all the way to the I value of n. All right, it's just we take it for granted that once we define the bounds of the summation as I, that it's going to be the same for both ends of that bound or boundary. All right, so example 1, see here it says that we have just a simple expression I that's bounded between I equals 1 and 6 instead of n. All right, so there is a cap to this, right? A known cap. All right, so we would make our first substitution. Our first substitution would be that 1 goes in for I. That's a little too thick, I think. Then add to that whatever you would get when you take the second number in that sequence from 1 to 6 and plug it in for I. That second number would be a 2. The third number would be a 3. The fourth number would be a 4. Then a 5. And then once we get to 6, we would stop. All right, so this would be the expansion of the summation notation or sigma notation. All right, so it would just be a matter of adding all these up. All right, so you can do that in a calculator. You do it in your head. Right, you could use different functions in the calculator to figure that out. So if I wanted to, I could just do, I could just do 1 plus 2 plus 3 plus 4, 5, all the way up to 6, and I get 21. All right, so I could do it that way. All right, another way to do it, and this is all detailed later in the notes, but I'm going to kind of steal my own thunder now. In the TI-84 calculator, alpha is kind of I don't want to say it's your best friend, but it's a good friend. All right? If you hit alpha and then work your way across the top row, you see a lot of different options. All right? One of them is a summation. If you put in your index, I equals 1, so whatever index you want, all right? The problem with the calculator is if you put a lowercase I in, it's going to think it's the imaginary unit, square root of -1. So pick something else, basically. All right, but let's say I go with a capital I, and I want to go from 1 to 6. Then I would put an I in there, and I get 21 that way. All right, so it's a nifty shortcut if you're into nifty shortcuts. Most of us are. All right. Then you see the second example from 0 to 5. Same general idea, except we're starting with an index of 0. I equals 0 going to 5. So expansion here would be 0 plus 1, 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1, and 5 plus 1. All added together. Alright, so the I is the thing that varies. Alright, goes from 0 to 5, but the 1 stays put. Now, on closer inspection, we see that 0 plus 1 is 1, we get a 2, we get a 3, we get a 4, we get a 5, we get a 6, all added together. So we now have a different summation that leads to the same outcome of 21. So, pretty cool, but also it kind of opens some more pathways for us. All right, we got to keep that in mind. Now, number 3 is going the other way. Write the sum. Now, this sum goes from 4 to 10 in terms of the things that change. In terms of the things that don't, well, we got the summation. The summation comes into play because we see those plus signs everywhere. All right. Now, I could start my index with a 4 and have it go to 10, but we kind of want to get in the habit of having our index start with a 0 or 1. So there's actually a bunch of different ways that we can write this. All right. First off, I know that it's going to be something raised to the second power. All right, because that 2 doesn't change. So one way to write it would be to say that my index I is going to start at a 4 and go to 10. In which case, it would be just I squared. Another possibility would be, instead of going from 4 to 10, I could say, all right, well, if I want I to be equal to 1, what would it take for a 1 to become a 4? Well, I'd have to add 3. So I plus 3. And just make sure that that carries its way through the whole way. Or it carries its way through the same way the whole way. All right, so if I becomes a 2, will that give you a 5? Yeah. If I becomes a 3, will that give you a 6? Yes. If I becomes a 7, will that give you a 10? Yes. So we want to go all the way up to 7 here. All right, so what this gets at is the idea that you have multiple different ways in which you can come up with the same expansion. All right. Whereas something like number 4 looks a little on the funky side. All right, we have k, so k instead of I. That's not a big deal. All right, we already know that the variable on the bottom represents the index. That's the thing that's changing. So this is saying that we're going from 1 to n, so 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus on and on and on and on and on until you get to 1 over infinity. All right. Well, really, 1 over n, if we limit this as n approaches infinity, then we could say infinity, but we can't really do that just yet. Getting a little ahead of myself. All right. So we end up with this expression. Now the question would be here, well, what do we do with it? All right. And so that's kind of a subject for a different topic down the line. All right. So we're going to leave it like that for now. All right. Number 5, we're going from 1 to 6. You see the little subscript of I there. That's the only thing that's going to change. Everything else is going to stay put. So f of x sub 1 delta x plus, set myself up for a little copy paste action here, 2, 3, 4, 5, 6, then I'll get rid of that little plus at the end, and then I'll just pop in Oh, 1, 2, 3, 4, 5, and 6. All right. Now I do have some room to kind of clean it up, so I'm just going to do that real quick. But that's all you can do because we don't have enough information. We don't know what the f function is. If I can get this to stay put, that would be nice. I don't know what the f function is, so that's really all there is to it. So we would just leave it at this for now. All right. So there's a couple instances where we were able to come up with a clean answer, and there's a couple instances where we have to say, all right, for now, this is what it's going to be, but later on we'll be able to do more with it, like 4 and 5.